As it is more a discussion than a presentation, this session, I wanted to talk about some issues in ecosystem service valuation, but more in the payment for environmental services. So what is important to me? Often natural capital, and in most of economic studies, natural capital in the provision of ecosystem services is not directly taking into account. I wanted also to highlight the different issues on the valuation of ecosystem service provision and how we could model that in a classical economic framework. As I said, I would like to talk about cost, but also co-benefits when you implement pro-environmental measures, and to look at how we can integrate all these issues in a effectiveness analysis of payment for environmental services. First, natural capital. There is a growing recognition of the importance of investing in natural capital in tackling current environmental crisis. This is in the famous report, very recent, of Dasgupta on about economics of biodiversity. What is the natural capital, in particular natural ecosystem capital? Natural ecosystem capital is a stock. And we have some examples: the soil, air, water that provide natural resources, and ecosystem services. Ecosystem services which are flows, and it's a kind of joke, including water. As you can see, water is a stock, is a capital, and water, as it is, when it is a flow, it is an water provision, for example, or water quality is an ecosystem services. I'm going to talk about soil natural capital because this support is from my point of view is easier to understand how we can integrate natural capital. It's a support of biodiversity and provides ecosystem service. And there exists very few economic models integrating or microeconomic model integrating natural capital, and in particular soil, and assessing its value. But of course, it's still highly interdisciplinary models. So I have a general conceptual model just to show you that we can apply this conceptual model to different soil, a different ecosystem, forest soil, agricultural soil, and even very modified by the human soils, like urban soils, industrial soils, and so on. And what is interesting to see is that natural capital, you can measure, you can give a precise definition of natural capital. This is why I call that N like natural stars, because it's an observed variable. But you can define broadly by 3 different states: physical state, chemical states, and biological states. And you know the function provided by natural capital, in particular soil. And from then you can measure how you provide the ecosystem service with a classical framework. Because ecosystem management means that there is a manager of the ecosystem, could be a forest or agricultural land, with classical production factors, and also physical capital. And it is important to have in mind that the quality of natural capital can be changed by different factors, like, of course, natural factors, but also human factor. And to be explained by the land use history. So these factors can negatively or positively affect this natural capital, mainly the soil. So the idea is, as you can observe and define the capital natural, to use observe indicators that soil scientists can give us to link the latent value of natural capital and indicators. I don't want to go into details of this model, but the idea is, once you dealt with this unobserved links, for example, in structural equation modeling, you can integrate in a classical production function. In my example, transformation function, because we have we provide different ecosystem services. You can integrate this natural capital beside the physical capital and the variable input that you can find in any production function. And as a dual approach, you can model this provision of ecosystem services by a variable cost function. A variable cost function is very useful because you can value the ecosystem, the provision of ecosystem service, so the supply function, but also value the natural capital. And in particular, you have several kind of measure of cost economy, very useful to measure, for example, the trade-off or the competition between ecosystem services through a concept used in industrial organization. And you can value, as I said just before, the capital natural. The other thing I wanted to talk about is how you can assess cost effectiveness of payment for environmental service. I know I'm very annoying guy when I specify it is payment for environmental services, and I don't agree with the notion of payment for ecosystem services, because you pay for the services given by the manager of ecosystem, and you are not reimbursing the value, the real value of ecosystem services. And by quantifying environmental and economic performance of this payment, it is very challenging, because there is a large, it's a bit what Laetitia talked about, a large number of causal factors at multiple scales, multiple ecosystem service, multiple aims and value dimension, and so on. Okay, I can go. Just this figure just to explain what kind of cost, and in particular participation cost and operating costs for the seller of ecosystem service, or if you prefer, the provider of ecosystem services. So, of course, you have the direct cost like input cost, incentive cost, but also transaction cost and opportunity cost to consider. I know that everybody knows that, but it's important when you have to estimate a cost function to have this thing in mind. So I want to talk about co-benefits of PES measure. The consideration of co-benefits, that means, that is a positive externality often, but that could be negative externalities. In assessing the cost effectiveness of PES is key, especially from a societal perspective. We have several works on that. For example, I know that my Amiri, my PhD student, is on the floor. We assessed the ecosystem services jointly produced by measure for water quality protection implemented by Nestlé Waters in the Vital catchment basin as a part of payment of ecosystem service scheme. For example, when you want to protect water sources against nitrate, of course, you improve the biodiversity because you decided to stop the use of pesticides or to reduce the number of the cows on in the fields and so on. So there is, and also we notice that people prefer to recreate, to have recreation activities in lands where there is no pesticides, even if they don't know where pesticides are. So co-benefits is what I wanted to say, have to be integrated in a cost-effective analysis, either directly, as we are going to, as we did in another paper with Valentin. So as positive value, if there are positive externalities, or indirectly. So it just to finish, it just, okay, finally, we have some ratio, I could say easy ratio of cost effectiveness, where you compared the cost of implementation of pro-environmental measure and the variation of impact. And okay, I don't want to enter in details of that. Just a small warning. The final impact is less than the baseline impact because it's a negative impact. So we were supposed to reduce the negative environmental impact. And easy way, maybe not, maybe it's not perfect, I mean, is to consider is the net costs, the benefits of over service. And as I said, we can measure that by valuation method, as we did in the works of Amiri et al. That's all is what, this is a reference I talk about. And I wanted to say that I know 2 words in Italian. Grazie mille.